Thank you everyone for joining. Like she said, we've had a lot of lovely sessions for this online session for the DevFest. I think I've spent some time as well to kind of watch some of the videos, and I'm incredibly grateful for some of the knowledge shared by some of those speakers. And I hope by the end of this talk, we will all be able to go away and having been able to absorb a lot of knowledge from this talk as well. So today the topic before us is building microservices with Go in the cloud. Just to begin with, Go is actually a programming language that I'm very, very passionate about. So it gives me a great pleasure today to actually being able to shine more spotlight on it and tie that to building microservices in the cloud. So we'll harness the power of Golang today to be able to build a scalable cloud native applications. Part of what we've had structured already will be a couple of microservices that have been built already. Of course, we're not going to spend a lot of time building that in this talk because we don't have a lot of time, but I will do my best to walk us through the code snippet and then still be able to get a lot out of it. So, yeah, there we go. So a bit of introduction. I think at the moment, cloud adoption, everyone will agree with me, it's one of those widely discussed topic in most organizations these days. Everyone tend to want to harness some of the powers and some of the flexibility that cloud brings, and then some are deciding, to entirely migrate to the cloud, while others have actually kind of adopted the hybrid approach of, still maintaining on premises, having some of their virtual machines on premises and some on the cloud as well. So, bringing all of this together, I think it's my hope that by the end of this talk, um, we'll be able to start building our microservices with Golang. And then for those who have not actually decided to embrace cloud yet, they can make that decision to be able to move to the cloud. So the agenda before us today is I will just quickly mention a few things that you need to know if you're going to get the best out of this talk. It's not entirely geared towards beginner, even though I'm going to explain some of the concepts that will be discussed, but I think some basic knowledge will still be required. I will mention that in a bit, and we'll just examine why microservices. Why do we need that? And why do I think Golang is an excellent choice for building microservices? And then quickly we'll look at some of the cloud native microservices architecture and some of the cloud native tools that actually make it easier these days to be able to build in the cloud. And follow closely to that is we'll look at the practical application. It's an hypothetical application anyway, but it's closer to what you have with e-commerce, but we have all of the services splitted into different microservices, and they will just focus more on two of the service. We'll take a look at it, and then we'll also deploy to GCP. So we'll be deploying the application to Google Cloud Platforms, and hopefully that should get everyone comfortable with migrating or deploying your Go application to GCP. So we'll just talk about a few of the benefits of using Golang in the cloud, and then examine some challenges and best practices and a couple of takeaways. So who am I? My name is Oluyemi Olususi. I'm a senior software engineer. I've been doing this for nearly a decade now. I started more as a back-end engineer, and then quickly migrated to, focusing more on DevOps and also a bit of front-end as well. I would say I have the full understanding of a software lifecycle, being able to work with different teams over the years. I've had opportunities of leading different teams, either in-house or remote engineers who work remotely, and then build a couple of different projects, from simple projects to much more complex applications, enterprise apps, and to building a lot of RESTful APIs for powering things like mobile apps, and then a couple of web services as well. I'm a lover of football and music, and I'm a fitness enthusiast. I tend to pride myself a lot in staying fit. That's that about me. And let's get to the prerequisite for this talk today is what you should know before we begin. Like I hinted earlier, I think a basic understanding of a programming language concept will really be very helpful for this talk. It doesn't matter if it's Golang or any other language that you're quite comfortable with, but I think some of those knowledge are easily transferable. Um, I hope you'll be using Golang at the end of the day, actually. Also, a bit of awareness of microservices and then REST APIs will actually benefit a lot. I will also advise some familiarity with the cloud platforms. I think it's, like I mentioned, a widely discussed topic, and most people are quite familiar with it. We'll just take a look at containerizing our application, so packaging everything and building an image, and that's what we actually deploy over to GCP, which will eventually run the applications. And some comfort with the command line. I think my belief is at the end of this talk or later on, people might actually want to try this out on their own. I think your familiarity with command line will actually give you that opportunity to be able to interact fully, because most of what we'll be doing will actually be from the command line. You're going to be using a couple of CLIs from Google Cloud and to interact. Most of those can actually be done from the dashboard as well, but we'll just be using that for this. It's easier to kind of automate and build that way. And just before we begin, before I get to the main part, I have a couple of maybe just hints or warnings ahead. Is by the time we get to examining the code and taking a look at it, I will be switching between screens just so we can see some of the performance. I'll walk us through the code base too as well. So just so we know that ahead. And of course, we're going to be deploying to GCP, like I mentioned. But in case there is any network issue, just in case, I have a recorded screen for some of those processes, and I can play that instead, just if I need to do that. Awesome. So before microservices, uh, there was an architecture called monolithic architecture, which was a standard. And I think even till now is still quite relevant. Depends on the scale of your application. But right now, everyone is tilting towards microservices. So monolithic architecture was a standard back in the days where you have everything deployed as a single code base. So meaning that you have all your code for registering, for logging, for carrying out things like maybe for e-commerce, for example, for shopping carts, managing your product inventories. Everything was built as a single code base. And definitely, most of these applications were actually written with one single tech stack, meaning you have just single one programming language for everything, and also a single artifact, meaning if you make some changes to the registration process, you then have to deploy the entire application all at once, even for the part that you've not made any changes to at all. So this was the structure back then. And then as time goes on, when the applications becomes a little bit more complex, and then it requires a bit of more structure, it becomes a pain. Becomes a pain to be able to deal with that. So traditional monolithic applications need some help with things like being able to scale and also being able to separate some part of fault. Because back then, if there's a problem with your product inventory, the entire application will be down, and then you will have to fix that, then deploy everything all over again. This is where some of the pain back then, and microservices came and then start destructuring everything into separate part. So for cloud native applications, you kind of require modular structure, and then to be able to have distributed architectures, which is where microservices come in. That's just a little bit details into what monolithic application was as a standard, and how microservices came in to try to change the game. So why microservices? I think I mentioned that a little bit just in the previous section, that when you build applications and separate most of the moving parts or some of the functionality and break them down into independent services that can communicate with each other, then you have microservices. An example that I've actually mentioned is an e-commerce platform, right, where you have authentication, product inventory, and then shopping cart, and maybe payments too as well. Now, when you break all of this down into separate services, it becomes so independent that each of the services will do one single thing. If a service is supposed to handle payment, it's going to focus on handling payment. If a service is supposed to handle authentication, it's going to focus on handle authentication. This comes with a lot of benefits, although it comes with challenges as well. So one of the benefits at this point is being able to scale the services that needs it. Although it sounds a bit counterintuitive, right? We feel like monolithic architecture introduce some problems, but then microservices were supposed to solve all of those. But it does also come with its own challenges as well. But some of the benefits is being able to scale service, splitting application into smaller services, like I mentioned, and also very important, fault isolation. So if there's a failure for payment services, that doesn't mean the entire application will be down. Users can still log in into your app because your authentication service is working properly, because your shopping cart is working properly, because your inventory is working properly. They can still come in, view all the entire product, but they might not be able to make payment because the payment service it's got some issues. So at that point, you can easily isolate the service that it's experiencing some bugs or that needs some fixes, and then you can focus on that and get that done. And also you can then have different tech stack. I think this is one of the benefits today where you have distributed teams. Some teams might be using Golang, some are using Java, some are actually building with either JavaScript or any other programming language that they prefer. So it's easier to have everything because you now communicate on a different architecture entirely. Few of the challenges is it comes with increased complexity in deployment and management. Now you have multiple microservices that you then have to deploy separately and then have to manage them. You have to check things like, are they LD enough? Can this service actually receive requests? Can this service communicate? Can other service communicate with it? Because in an ideal world, what will happen is you have different services that are dependent on each other. For example, my payment service or my registration service might actually depend on email service because you need to send out email. So it comes with complexity of managing deployment and also thinking about communication between all of the services too as well. So the very good part of this talk is why choose Golang for microservices. Um, the syntax and high readability of Golang is one of those things. Like if you take a look at the code snippet that I have on the right side of the screen, you see how the functions define a greet function, and then you can call that function within your main function, which it's more like the entry point to your entire application. This is quite visible and easily for someone who's a new developer could come into the team and then start get onboarded easily, although there's still some sort of knowledge which you need to understand what the syntax looks like, but it's quite readable and very relatable to everyone. It kind of reduces any extra complexity, and then it's easy to get new developers on board. And in terms of performance, this is one of the major selling points of Golang is concurrency. It's a built-in concurrency. This is when you have a Go routine. A Go routine, it's more like a thread, still a thread for your application. So you could have that spawn up and then running separately, and then you can get result back from that. That way, you can easily manage a more complex application. We're going to see more like some sort of metrics for this in our services that we'll demonstrate in a bit. And also, you can build a complete HTTP server with Golang. It just comes with some built-in HTTP server. So you don't have to depend on an external third package to be able to build an HTTP server or handling things like JSON response. And when you look at the cloud world generally, most of the cloud native application tools like Docker and Kubernetes, Terraform, most of them were actually built with Golang, so which makes it very applicable to the cloud. Just highlighting what Go routine is. This is an example of a Go routine. At the end of the day, Go routine is still more like you have a function that will start running when you're within your application, but in a way, it doesn't actually stop the entire application from running. It just kind of spun up and then speed up the process easily. So a Go application, it's a routine on its own. It's a thread that keeps running. But then when you spin another one up, it separates that from the main application itself so that this can actually handle complex processes and then return the response back. So taking a look at cloud microservices architecture, I mentioned earlier about containerization, being able to manage when you have multiple services and then how the application handle things like failures. So let's start with containerization. When you have applications, this is where Docker comes in and then building an image. So when you containerize your application, you build the entire application, you build an image out of it. So that includes things like dependency of the applications, what it needs to run on any host machine. You build that and then package it. So this image becomes what you can deploy. It's deployable units that can be run anywhere on any operating system. Then this will eventually start running your application itself. And then orchestration, this is where Kubernetes comes in. So when you look at multiple services, we're going to take a look at the diagram of different services in a bit. But when you have multiple services running, you need to be able to coordinate the service. You need to be able to check that a particular service is LD enough to receive HTTP request and the response. Because if a service is down, other services that depends on it might just keep sending requests, hoping for a fulfilled response. But if that service is down, nothing is there to kind of indicate that the service is down, or nothing is there to restart the service and make sure that the service gets back into an healthy state, or being able to manage traffic for some of the services. And this is where Kubernetes come in. Think of it as more like an orchestra of, you have different groups, and then someone kind of controls them and then guides them to bring a lot of harmony out of their performance. So when you have different services, you have Kubernetes handling and monitoring all of them. And also you could do things like check the logs, monitor the performance, and then do traces in case there are failures. You could track down which service is failing. Also for resilience, where you have service failing, and if you're not getting response back, you could put in things like retry and then undo things like timeout as well. And on GCP, you have Google Kubernetes Engine. This is the managed Kubernetes for deployment. This is on GCP. GCP handles all of that, and which is part of what we're going to use today. And also global load balancers, which manage traffic. So if there's a request coming in, and then you have different pods, more like a replica of each of these applications running, the load balancer is able to detect which one is being overloaded and then route traffic to a different one that will be able to handle it at that point. So this is a case study that I mentioned earlier. You have microservices, you have a shopping cart service, you have user authentication service, product inventory service, email notification service, and payment, right? Back when it was monolithic architecture, all of this could be in single application, but with microservices, we separated them into different independent service. It can actually get more complex because some of them actually have their own database running. But if you have services that depends on another one, and then that other one needs to set up his own database, that might reduce the complexity a bit. But this is as simple as it can get when you separate your services into multiple microservices that does one thing at a time. Now, user authentication will basically just handle authentication. Payment will just focus on payment without trying to send email because there is a service for that already. Yeah, I hope everyone is following. If you are, you can just give it thumbs up. Cool. Awesome. And I think I see some questions coming in already. So being conscious of time as well. Like I said, we're going to focus on two of the service, user authentication and email notification. So think of this scenario. You register a user comes to your platform, they register, and then you trigger an email service, which is only to send transactional emails, like welcome emails, or you want to reset your password, or you've actually successfully add to your cart, or you've actually ordered a product, things like that. And that's what the email service will just do only. All right, that's a lot of theory. That's a lot. So we'll just take a look at the code now, see some of the implemented service already, and then I will do more like a code walkthrough. And then we also look at the manifest file for interacting with Kubernetes to be able to deploy this application to the cloud. Okay, we'll just switch my screen to show email service. So there are different part of this code, but I think I will just focus on few functions, the major part. I will also share the link to this at the end of this talk, just so people can download and then walk through it. So this is the function that actually send emails. But I think it might be best for us to start with user registration first. Yeah. So this function, register user, this function takes a request and then decode that request if there's any invalid, and then it just kind of return the response. And then it depends on a function, another function to register user. So that function is also separate within this code. But basically what happens is it makes that call with all the requests and then register the user. And then once that user is registered successfully, it sends an email. This is the email request. And then what happens here is it makes a call to the email service. This is the URL of email service. If we're running it locally, it's going to be on port 8081, but we have an email service, which is in the configure environment. And this URL is just the URL of the service for email. This way, it's easier to just make that call directly to the email notification service and then send an email. And this will just spin up on its own and then continue working, send that email. If you fail to send an email, you're going to get a response for that. And if you're successful, you're going to get the same different response as well. So this first one is a synchronous way of sending this email. But part of where Golang shines is if I just uncomment this temporarily, we'll see we have a go func here. This is the concurrency. So this email will be sent asynchronously without blocking the entire process. So which means you can even see a response that the registration process is completed while the email service is actually just doing its own thing and working through sending that email. So we're going to deploy and test with concurrency and without it. And then we'll just compare the time it took to complete that process so that we can see some of the benefit that Golang has got to offer. And for deploying this user authentication service, we have this manifest file. This is a YAML file. This is the standard of deploying to Kubernetes. So where you have what kind of service will this be? Is going to be a deployment kind. And then what the name of service is. And also, we're going to deploy to GCHAR. I think I forgot to mention this. GCHAR is the Google Cloud Registry for images. This is where you build your image. from container, you build that image, and then you deploy to GCR. It's a repository just for image, the same way you have for Docker Hub. So we're going to deploy our image to that environment. We're going to retrieve from there. And this is the email service config that I mentioned earlier. You see how we just have email service here? This is made available because we have a different service named as email service. And now Kubernetes will be able to use a service discovery within the cluster, because all of this service belongs to a single cluster, right? You have user authentication running in there, email services running in there. With this name being defined, it's easier for Kubernetes to then be able to detect which service has this name. And of course, this will be exposed to a load balancer so that it can route traffic. Because the user authentication service is supposed to be exposed to the user and not within communication, just within. But if by the time we check email notification service, you're going to see the difference between this. That's just a brief about that. And if I go to the email notification service, this is the function that mainly just send that email. It actually depends on Mailgun to be able to send email, but we're not going to send email in this service. We're just going to run a simulation to register user. So we're going to run a simulation to register close to like 120 user at the same time, but we don't want to overload the email provider for that. So we're going to comment that out. But if this were a single user, it would have been easier to do that. To control that process, we're going to use this email simulation mode, which is part of our service already. Now, let me take a look. Let me explain again what we have for this function is it decodes the request and then sends an email. That's just more like a summary of it. And to deploy it, we have this manifest file. This is similar to what I showed for the user authentication service earlier. Now, it does have a couple of secrets for Mailgun related ones. And of course, for this simulation, we're setting it to true so that once this is true, we'll be able to run simulation without sending out any emails at all. I know I've just rushed through the code snippet there, but this is just a simple way of setting up and then deploying. Of course, this image service is going to come with 3 replicas, which means we have 3 pods, and I'm going to show us that in a bit. So this is what we have for these 2 services. What I will just attempt to do now is try to deploy them. But if we go back to the slide, as we've seen from the code, this was built using Golang, and then deployment will manage via Kubernetes on GCP. So for the steps, we've written the Go-based microservice already. I will share the link later on. And then we're going to Dockerize each of the service. There's a Docker file in each of those repositories too as well. And then use Kubernetes manifest for deployment on GKE. So to test, we're looking at inter-service communication between the user authentication service and then the email service. So what happens is a user visits the platform, they register, a call is being made to the registration endpoint. And then once it's registered successfully, another call is made to a different service, which is email service in this case, to a specific endpoint. That's a send endpoint. And then that way, it communicates with Mailgun and then send out email. So let's cross our finger and take this for a spin. So I'm going to try to deploy this now. So just what we have right now is we have the user authentication service, and this is going to be synchronous at the moment. We're not making changes, but I think I've just made some changes earlier. So if we're going to deploy this, taking a look at the Docker file, this is what will be built. I mean, this Docker file will actually be what we, so I have sequence of step already to be able to go through this. So I'm going to copy some of those scripts, paste it in the terminal, build the image, and then deploy. But just in case of anything, or just to save time, I think I will just run us through some of the recorded screen already. So this was recorded. If you have, by the time you make changes, you'll have to take this script. So you have a Docker command to be able to build the image and then deploy directly to GCR. Also, there's a lot of steps involved in setting this up when you start. And I've just put together more like a study guide or user guide, if you say, to be able to guide users through setting up your GCP, creating a project, setting up a billing account, and then once you're done with that, you then be able to deploy it directly from the terminal. So from this screen now, you see we've just built an image for the user authentication service on the right side of the screen, which is done already. But there's a bit of delay for the email notification service. So we're just going to wait for that just a little bit. And I can forward that so that we'll see that is completed already. So this will build the image and then also push that image to GCR. So with this, we can see that this is completed already. You can restart the deployment if you want to, and then this way we're done with deploying, even if we make changes to each of those at all. That's for that. And then if we take a look at the other one, if we're going to build with concurrency, I'm just going to play this video as well. So with this, we've actually deployed both our images to GCP. This is just using Kubernetes to check the log of each of the service. We have the authentication service, and then we have the email notification service, both of them running. From the code that I showed you guys earlier, we see we have 3 replicas for the email service, which is why you have 3 of the services running. And then we have 2 replicas for the user authentication service, which is why we have 2 of those running. Now, I have a script to be able to create close to 120 user, and I'm just going to play that so that we see. Now, when you run the script, just take a look at the terminal to see the response. You see users 1 being registered, and if you take a look at the terminal for the user authentication, you see how the email processing is going on. And this is happening in microseconds, right? When you take a look at, for example, you see each of them is, for example, 91.02 microseconds. This is how fast it was with using concurrency in Golang. I think it hangs a little bit for some of them. I'm just going to skip this forward so that we can see everything done completely. Now, this has actually completed registering close to 120 users. There was a timeout in one of them. But when you look at how long it took for all of this to be completed, then you can compare the time the email was sent, where the registration process was also completed. This was in microseconds. And this was actually using concurrency. Now, if we check without concurrency, if we play that as well. So by this time, I've made the changes to the code. I've actually uncommented the code to run it concurrently and then use the synchronous one just to compare how fast it took for the process to be completed. So instead of microseconds, you can see that most of these email registration were completed in milliseconds. So some of this difference in the metrics might not be entirely noticeable for an application that is as simple or small as this, but it makes significant changes when you have large applications and you have tons of users. For example, we're just registering these users without sending email. But imagine what will happen when you have an application where you have multiple users currently visiting your site and carrying out this process. The difference between microseconds and milliseconds can actually make a lot of impact on the performance of your applications and how responsive your application is to the users. So this is what the performance looks like when you compare the metrics with each other. So for some of the benefit of using Golang in the cloud, one thing is efficiency, how handles high concurrency load effortlessly. Like we saw from that metrics, registration process was being completed in microseconds when we were actually using concurrency, and in milliseconds without it. Those little metrics and data could actually take a lot of impact, make a lot of impact on your performance, and is optimized for cloud environments with low resource consumption. Also, it's easy to scale individual service independently. This is actually be handled by Kubernetes itself. So you could easily increase the number of replicas if you feel like your service will actually take a lot. By default, you could have tons of replica being spun up. I think there's a limit to the number. I can check that. But that way, Kubernetes will dynamically scale your pods too as well when you notice that there's more traffic than your existing pod being run. And also quick iteration due to fast compile time and clean syntax. It's easier to just also being able to manage your release. You can easily build separately service and then deploy them. It's just a simplified process. So if we had included CI/CD in this as well, this will actually manage things like building your Docker and ensuring that you have different versions of it rather than just a single version. And then you can have different versions being run independently. So few challenges. I think we mentioned earlier that we have microservices came to solve a lot of problem, but it can also come with challenges as well. For example, when you need to debug and manage multiple services, you'll have to check which services got the issues, and then you go to that service, maybe check the log and track it. And if you don't have a lot of resources or a lot of software engineers who can actually take a look into this, it can actually be a pain trying to manage all the multiple services. And also things like latency and failures in intercommunication service. Your authentication service might be expecting email service to be up while it's communicating with it, but that might be down for a split seconds. You know, and when you know that when you have your users using your application, it's every little time count. So splitting that little seconds could actually be something of concern. And also monitoring and ensuring visibility into the system health. Some of the best practices that I think I will kind of encourage for this is using tools on GCP to be able to trace your applications and then also manage them, and maybe automating deployment. You see, what we have is at the moment, if I make changes to my code, rather than deploying to a repository like GitHub or Bitbucket, all I'm doing is making the changes and then deploying straight to GCP. You could have this entire step automated. And what you can do is once you make your code changes, you deploy to a code repository. And then from the code repository, you have a couple of steps that will run, and you automatically just deploy your application to GCP, deploy your image to GCR, and then deploy your application to GCP and then run it without further interaction with you, with any human at all. So automating that comes with a lot of benefits, and also resilience as well. What happens when a service tries to communicate with another one and then it's not getting a fulfilled response back? So you need to be able to set up a retry logic to retry a couple of times before eventually timing out. So as we wrap up, few key takeaway here is microservices offers modularity and scalability. And most importantly, I think fault isolation is one of those selling points where you have things separated and then you can easily track which of the services got issues, and then you can focus on that, fix it without taking down your entire application. And also Golang simplicity and cloud native feature makes it ideal for microservices. This is one of the major things that I want to, if there's nothing, one major thing that I want to highlight today is this feature for Golang, concurrency, and some of the inbuilt libraries that won't make you depend so much on external third-party libraries to be able to build a successful application. And GCP and Kubernetes simplify management and deployment. Kubernetes handle things like spinning up a couple of pods for you, managing different pods that are running within your Kubernetes cluster, and then being able to check the health of each of your system, managing traffic as well. And of course, GCP gives you that platform to be able to scale your app, build as much as you want, and then use tons of tools that are available in the industry. So next step will be, some sort of recommendation here is, try and build and deploy Go-based microservice on your own. And I think I also advise that you explore different GCP product offerings and eventually be able to use Kubernetes to deploy your application. Yeah, that's about it. Thank you everyone for joining today. This is the link to the repository, some of the services that we checked out earlier, and also the service to be able to simulate users as well. This way you can generate, just to test the performance of our application, you can create multiple users, of course, without sending out emails, because we don't want to overwhelm the email provider's server, with registering 200 users at once. But this is just for testing purposes. And of course, I also have a deployment guide that I put together to be able to set things like what you need to install on your application, on your machine, to be able to deploy to G Cloud, to deploy to GCP, some of the major commands. And these can also be shared at the end of the talk as well. So that's about it. I think if we have questions, I'm happy to take some questions. Patty, I think you're on mute. I can't hear you.
Yes, I was. Thank you. Thank you so much. It was really an amazing presentation. There is a question by Marcia in the chat. Is it feasible to learn this on an individual personal project, or can we see the actual application of this technology on big projects in big companies?
That's a very good question. I think to do this on a personal project will come with a lot of cost. That's just being honest, because some personal project might not require you to separate into multiple microservices, except if you're building for a client that has, each service and requires that you could separate it. But if it's just for personal project, it might not be entirely applicable, especially when you have to also deploy to environments like GCP, right? Then you'll have to separate multiple services. You have to enable billing and pay for tons of those services too as well. I think it's really applicable in large organization. Is more practical when you can actually, bring this to your organization and then help them scale the application easily by suggesting view products, by separating into different microservices. This way it's easily manageable, even when you have tons of developers too as well, who could actually, because of their expertise, work with different programming languages.
Okay. Well, thank you. Thank you so much again for sharing your time with us and our community. And I would like to say thank you for the people who joined. This will be uploaded to the GDG Glasgow YouTube channel. And we have another session coming up in 10 minutes and then another one at 2 p.m. So I hope to see you all there. And yeah, thank you again.
Thank you. Bye.